and we're gonna look at a new method here in this video. Right, you see, when we have y equals to 2x minus 3 square in a bracket, how do you differentiate this? I mean, we can expand this, of course, we can expand this, right? So y will be equals to 4x squared minus 12x plus 9, right? And after that we can do dy dx as usual. So dy dx will be 8x minus 12. That's very easy, right? But we could expand this because it was to the power of 2. What if it's to the power of 3? And what if it is the power of 4? Power of 3 can still be expanded, but not easy. Power of 4, you can say that we don't want to expand this because it's gonna consume too much time, right? So how do you differentiate this? See, this is why we need a new method. Let me introduce to you the bracket method. Right, the bracket method is called the bracket method, or in my notes I usually call it BM, bracket method. Right, it's called the bracket method because we differentiate an equation without expanding, without opening up the bracket. Right, so for example, here we have y equals to 3x minus 7 in bracket to the power of 8. Definitely we cannot expand this, so we have to use the bracket method. So how do we use the bracket method? We can straight away do dy dx. So dy dx will be equals to, what you do is the 8 you bring in front, right? And then the 3x minus 7 you just copy. But the power of 8 you have to minus by 1. And then this is the tricky part, the important part. What you have to do is you have to differentiate the inside here. So what we do is we assume the inside of the bracket is 3x minus 7, right? So what we do is we assume y equals to 3x minus 7, right? I just assume that y equals to 3x minus 7, and if you differentiate that, when you do dy dx, what do you get? You get 3. So that is what you put outside here, 3. Right, so you differentiate the inside of the bracket and put outside here, and then you multiply 8 and 3. What you get is dy dx equals to 24 3x minus 7 to the power of 7. You see, you don't have to expand to do bracket method, right? So for questions where that it looks like this and you cannot expand, this is the only way you can differentiate it, right? So let's go back to the questions just now. All right, so we had here y equals to 2x minus 3 to the power of 3. We don't want to expand this because it's going to take too much time, right? So we use the bracket method, right? We straight away do dy dx will be equals to 3 2x minus 3 to the power of 2, because 3 minus 1, and you differentiate the inside, you get 2, right? And it's so easy, you get dy dx equals to 6 2x minus 3 to the power of 2, just like that. Easy, right? This one, dy dx will be 4 in bracket 2x minus 3 to the power of 3, because you minus 1, differentiate the inside, you get 2 again. So what you get is dy dx equals to 8 2x minus 3 to the power of 3. You don't have to expand, guys. If you don't want to, you don't have to expand, right? So can we actually use the bracket method for this one? Of course we can, right? You see, y equals to 2x minus 3 to the power of 2. Let's say for some reason you don't want to expand that. Yeah, you can use bracket method, right? Where dy dx will be 2x minus 3 to the power of 1. Outside will be 2. And you get dy dx equals to 4 in bracket 2x minus 3 to the power of 1, and if you notice, you times the 2 inside, you're gonna get 8x minus 12, same answer, right? So it shows that bracket method works, right? Because we got the same answer, right, with this one where we expanded it, right? So bracket method works, guys. So if you cannot expand, you have to use the bracket method. Let's look at more examples. Number 2a here. We have y equals to 1 minus 8x to the power of 6. We definitely do not want to expand this because it's to the power of 6. So we do dy dx and you get 6. 1 minus 8x to the power of 5, and when you differentiate the inside you get negative 8. So you get dy dx equals to negative 48, 1 minus 8x to the power of 5, and that's the dy dx, guys. Right, how about this one? Interesting, because we have x to the power of 2 inside. No worries, no problems at all, right? We straight away can do dy dx, which will be equals to 4 x square minus 12 to the power of 3, and then you differentiate the inside. When you differentiate x square, you get 2x minus 0. So when you differentiate the inside, you actually get 2x, right? So what we get here is dy dx equals to 8x x square minus 12 to the power of 3. Alright, how about this one? Right, also to the power of 5, so we cannot expand. So we do dy dx equals to 5, the 5 bring in front, x cubed minus 2x to the power of 4, and then when you differentiate the inside, you're gonna get 3x squared minus 2, right? So that's the answer. You cannot simplify anything, so you can just leave it like that. I mean, you can rearrange this if you want, but you don't have to also, right? It looks nice like that, right? So that's how you do the bracket method, guys. Let's look at more examples. Right, number 3 here. Interesting. Right, we have a very long bracket here, but there's no problems, right? We can do dy dx equals to 10, you bring in front, 10, and x square minus x minus 6, nothing happens inside that yet. The power of 10 will become power of 9, and then you differentiate the inside, you get 2x minus 1, and that will be the answer. Or if you want, you can rearrange, because here the power is higher, you can also write it as 10, 2x minus 1, x square minus x minus 6 to the power of 9. Yeah, probably it looks better like that, but both are correct. Right, how about question B here? Power of 8. So dy dx will be 8 4x minus 5x squared to the power of 7. Differentiate the inside, you get 4 minus 10x. Now this is very interesting, right? The differentiation of the inside is 4 minus 10x, right? So okay, we can rearrange like what we did just now, so it becomes 8 4 minus 10x, and then 4x minus 5x squared to the power of 7. But you realize that 4 minus 10x, you can factorize further. You can take out 2. You see, if the power is 1, you can take out, you can factorize and put outside. If you don't, it doesn't look the most beautiful, right? So if you can factorize, like we don't factorize from here because the power is 7, so you cannot take out anything. But here the power is 1, and 4 and 10 you can take out 2, then you should, right? You take out the 2 from in there times with the 8. So the most beautiful answer for dy dx will be, you take out the 2 times with 8, you get 16. Inside here will be 2 minus 5x, and then 4x minus 5x squared to the power of 7. That will be the best answer for the differentiation of this. Right, amazing, right? Let's look at more examples. Number 4 here. So the thing here is, right, we have a number outside of the bracket. Should that bother us? No. You know, we can still do bracket method, no problems at all. Just leave the 2 there. So what we get is dy dx will be equals to 2. Bring the 5 in front. Right, this will become 3x minus 7 to the power of 4. Differentiate the inside, you get 3. Multiply everything, dy dx, you get 30 times 3x minus 7 to the power of 4. Beautiful, beautiful. Right, how about this one? Same thing, you can straight away do dy dx. That will be 1 over 2. The 10 bring in front, times with the 1 over 2. X minus 1 to the power of 9. And you differentiate the inside, you're gonna get 1. So we get dy dx equals to 5 x minus 1 to the power of 9, and that will be the answer for that. Right, now this is very interesting. Right, you know, we had numbers outside of the bracket just now, so there's no problems with that. Right, but here we have an x outside of the bracket. So can we still use bracket method? The answer is no, because every x from the equation must be involved in that transformation that we call differentiation, right? So you cannot just ignore the x outside here and go on with the bracket method. Cannot. If you have x outside of the bracket, you cannot use the bracket method, right? So how do we differentiate this? Luckily, the power is only 2. So we can actually expand this because the power is 2. So we expand this. So we get y equals to x. Expand this, you get 4x squared minus 4x plus 1. Right, times the x inside, y equals to 4x to the power of 3 minus 4x squared plus x, and then you can differentiate like how we did before. Dy dx equals to 12x squared minus 8x plus 1. Yep, so there's no problems there, right? But this one we got some serious problems, right? Because we cannot use bracket method here, right? Because we have x outside. At the same time, we cannot expand because it's to the power of 3. So first of all, here we cannot use bracket method. Number 2, right, we also cannot expand, right? So we have to conclude that we cannot do this, right? We cannot do this yet, right? Because we're gonna learn a new method to tackle that. But remember, you cannot use the bracket method if you have x outside. Numbers got no problems, constants got no problems. Say if you have pi outside here, no problems, but you cannot have x outside there. Let's move on to the next example, guys. Oh, interesting, right? We have y equals to 1 over 3x minus 4 to the power of 2. So what do we do here, guys? Yep, we can bring the whole thing up, so we get y equals to 3x minus 4 to the power of negative 2, and then differentiate using bracket method as usual, right? So what we get is dy dx equals to negative 2 3x minus 4 to the power of negative 3. Differentiate the inside, you get 3. So dy dx will be equals to negative 2 times 3, you get negative 6. This one has a power of negative 3, so we bring it back down, so it becomes 3x. Oh my goodness, I'm so sorry guys. 3x minus 4 to the power of 3, and that will be the answer for that. right? How about this one? Same thing, right? You have to bring the whole thing up. There's no other way, right? So y will be equals to 1 minus 3x to the power of negative 1. So we straight away do dy dx and we get negative 1. 1 minus 3x to the power of negative 2. Differentiate the inside, you get negative 3. So what we get is dy dx equals to 3 over 1 minus 3x to the power of 2. That's what you get. So question C, same thing, bring it up. So y equals to 4x square minus 1 to the power of negative 1. dy dx equals to negative 1. 4x square minus 1 to the power of negative 2. Differentiate the inside, you get 8x. So dy dx equals to negative 1 times 8x, you get negative 8x over this, bring down, you get 4x square minus 1 to the power of 2. That's the answer, guys. Right. How about question D here? We have 8 on top, but you know that doesn't bother us. Y equals to 8 times 2x minus 3 to the power of negative 1. Therefore, dy dx will be 8 times negative 1, 2x minus 3 to the power of negative 2. Differentiate the inside, you get 2. So dy dx equals to negative 16 over 2x minus 3 square. That's what you get. Alright, so let's look at more examples, guys. Yeah, we have the third ones. Right, again we should change the third form into index form. So this will become y equals to 8x minus 1 to the power of half, and you cannot expand that definitely, so we have to use bracket method. So what we get is dy dx equals to 1 over 2, bring in front, 1 over 2 times 8x minus 1, 1 over 2 minus 1, you get negative 1 over 2. Differentiate the inside, you get 8. So dy dx will be 1 over 2 times 8, you get 4 over, bring this down, so it becomes 8x minus 1 to the power of half. You don't have to change it into third form, you can leave it like that. That's the answer. Right, like this you have to change it into index form and also bring it up. So what you get y equals to 6x plus 5 to the power of negative 1 over 2. Correct? Yeah. So dy dx will be negative 1 over 2 times 6x plus 5, negative 1 over 2 minus 1, you get negative 3 over 2. Differentiate the inside, you get 6. Therefore, you get dy dx equals to negative 3 over 6x plus 5 to the power of 3 over 2. Right, so that is how the bracket method works, guys. And the bracket method is compulsory. You must master it, because if not, certain questions you cannot do. So I'll see you all in the next video. You can practice all these first. Right, bye guys, take care.